Welcome back. Section 19.6. This is the last of our sections that have reversible reactions at carbonyls. Then we're going to learn some irreversible reactions at carbonyls. So with hydrocyanation, let's take a look at the general reaction. If we take a carbonyl compound, and these can be aldehydes, if I can spell, aldehydes or ketones. If we react them with hydrogen cyanide, yes, that famous hydrogen cyanide that you might have seen in movies, that the bad guy, when they're caught and cornered, they break their tooth and they swallow the hydrogen cyanide to commit suicide in order to avoid being captured. That's the same hydrogen cyanide. It's actually a very useful reagent, but it turns out it reacts reversibly with these and makes the cyanohydrin. This is called the cyanohydrin. We've seen this before with halohydrins. Halohydrins had a halogen and an alcohol on adjacent or vicinal carbons. In this case, the alcohol and the cyanide are on the same carbon. Now, the way that you keep this stable is that you maintain slightly acidic conditions. Okay. And under these, the equilibrium shifts to the right. If you put it under basic conditions, the reaction will actually reverse. So that's the way you control it. So let's look at a specific example, and we'll see that this can be useful to very quickly make complicated structures. So if we take something, let's say as simple as benzaldehyde, and we react that with hydrogen cyanide, we have made a carbon-carbon bond. Okay, now again, this is a carbon-carbon bond forming reaction. And you should be classifying all of your reactions, we're learning lots of them, in terms of carbon-carbon bond forming, carbon halogen, carbon oxygen, and so forth. All right. So what can we do with this? It's actually what we can do with these products. So I'll draw it over here again. This is manganylnitrile. The cyano group is very useful. We can, for instance, hydrolyze it. If we treat it with acid and water and a little heat, you can hydrolyze the nitrile to the carboxylic acid. Now these, again, this is the alpha carbon, and so these are referred to as alpha hydrox or alpha hydroxy compounds. If you're familiar with the beauty industry, the anti-aging creams, alpha hydrox, those are alpha hydroxy carboxylic acid compounds. They reduce puffiness and help lines and things go away in the eyes and skin. So that's a very large, the beauty industry is a multi-billion-dollar industry that makes use of these compounds. The other thing we can do with them, for instance, is just treat them with lithium aluminum hydride, and that will reduce the nitrile to an amino group, and these are amino alcohols. And and they're very useful compounds in many, many, many syntheses. Lots of things have an alpha or a vicinal hydroxyamino group relationship. So hydrogen cyanide is toxic, and so you always have a plan how to deal with it. We've used it in my lab before, never had a problem with it, because we know how to handle it. It's about mitigating risk, you know. SpaceX sends people into space. That's a risky business. You manage those risks.